After we've set up our modeling, set up that we have our basins and clarifiers, we're going to now model the oxygen system. We're going to do an oxygen analysis. And again, using the modeling, what we typically do is we just go right down the menu items. We're going to develop a KLA, we're going to generate an oxygen transfer capacity curve, we're going to determine our oxygen utilization coefficients, and then we can run an oxygen status evaluation report. So I'm going to start at the top. We're going to develop a KLA for system. So what the KLA does is really a measurement of the ability of your aeration system or your aeration devices to transfer oxygen in. And many times we get a KLA from the manufacturer. That's typically done in ideal conditions with tap water, wherever in the manufacturer's parking lot, and they come up with an oxygen transfer capacity and they develop a KLA. But what we're going to look at is what your devices can do right now after maybe years of use, fouling, whatever's going on. And we developed this KLA by essentially running pairs of DOs and OURs throughout your system. So what we want to do is we want to come up with, we want to run a dissolved oxygen of 3 and find out what our OUR is at 2.5, at 2, changing our dissolved oxygen. Maybe we have to turn off blowers, and we want to do this in a grid around your basin to make sure it's well mixed at different depths, things like that. So the more pairs you type in, the better. And so what you're going to do is for each basin, you're going to develop this KLA. So I've chosen basin 1. It has 4 basins. That's because that's what I set up. Let's say it's 20 degrees, and I'm going to type in a beta number. And beta is a constant that we use, and it's generally accepted somewhere between 0.95 and 1. I've used the default of 0.95. Technically, it is the ratio of the saturation concentration of your oxygen in the wastewater to that of the local tap water. Again, I've always used 0.95, and it's worked okay for me. So I've done my test, and in here I'm going to type in some numbers. And again, the more pairs you do, the better model you're going to get. But I've got 2 dissolved oxygen at 2 and a paired OUR. Did an oxygen uptake rate test of 24. I've got 3, let's say 28. And at 2.5, I was at, or 2.6, I'll say, I was at 16. I'm going to go ahead and click calculate, and it says, do you want to save that computed KLA to the database? And it's going to save it for basin 1. So I'm going to go say yes. And honestly, I can go through now and do it for each one. So maybe this one, when I did a 3, I got a 26, and I got a 15 here. So that one's 86, so forth and so on. And I'm just going to quickly go through and generate each one. Now, again, we know this is a lot of work. I've done a lot of testing here, but actually using the software at this point, after you've done the testing to calculate this, it's very straightforward. So now I have a KLA, so I know how efficient I am at transferring oxygen into my system for each one of my basins. The next step is to generate an oxygen transfer capacity curve. So I'm going to run all 4 of my basins, and again, I'm going to say I'm at 20 degrees, and my beta, again, is at 0.95. So I go ahead and plot, and what this graph shows me is how much oxygen I can transfer into my system given certain dissolved oxygens, okay? So what I'm going to do, shrink this graph down a little bit so we can see. So if I change my dissolved oxygen, if I want to run a different dissolved oxygen, I'm going to drop from 3 to 2. What this graph tells me is that, well, if I run a 3, I can produce, or I can transfer in about 10,000 pounds of oxygen into my system a day. If I maintain a 2, I'm up at 2,500 or 12,000, something like that. So I can see what happens. Now, what we're going to find out later is how much oxygen is required based on the loadings that we're going to see. So I would want to print this graph and set it aside. As I change things, I can find out, well, at different DOs, what's going to happen, and do I have enough oxygen to treat my loads? So I set that graph aside. Now I'm going to go in, and like I said, we're just going to go right down. So I've generated the transfer capacity curve. Now I'm going to determine my coefficients and plot some things. So what I want to look at is August of 2013 is the dates I'm going to analyze. And again, I'm going to run all 4 basins. And the first thing I'm going to do is I'm going to calc coefficients and plot. So what this does is it calculates the sour and the endogenous respiration rate, and it shows me a coefficient of correlation for that calculation. So it's plotting pairs again of specific oxygen uptake rate, that variable, against our food to mass ratio, and it's coming up with these equations. What this graph shows me, and really what I'm interested in, are these coefficients that we've calculated. So what I see here is the substrate oxygen utilization rate, which is really the food coming into the system. So I'm going to use 0.6316 pounds of oxygen to treat 1 pound of organic material coming in. That's the food getting fed into my system. But I also have bugs, or for lack of a better term, I've got endogenous oxygen requirements. So that's the requirement of just the mixed liquor just sitting there. And so for every pound of for every pound of mixed liquor, I require 0.06925 pounds of oxygen to treat that. And I got a coefficient correlation of 0.658. That's just a number that tells you the goodness of fit. How good was that? Is this prediction? A 0.658 means we're pretty good. We'd like something above 0.7. And again, it'll vary on the data, and you can run it for different months. But once I have these coefficients, now what I can do is go in here and click Plot Organic. What it's going to allow me to do is look at different organic loads and a different mixed liquor to see. So I'm going to say my minimum load is 5,000 and my maximum load is, let's say, 20,000. And I'm going to run a mixed liquor of 3,000. So what I see is if I run a mixed liquor of 3,000, and if I get a loading of 10,000 pounds, I'm going to have a requirement to produce just over 10,000 pounds of oxygen. So again, if I wanted to go and looking at the oxygen transfer capacity curve or graph that we did in the last section, I can find out, well, at a DO of 3, I can produce or transfer in 10,000 pounds. So in this case, if I want to maintain a DO of 3, I really can't get enough oxygen into the system to treat my load. And obviously at 20,000, now I'm in real trouble. Okay? So you use these graphs together, and then you can say, well, what if I want to, change my mixed liquor? I can plot it again and say I'm going to run at 2,000 and see how my oxygen. So now at 10,000, I only have to transfer in 9,800. So now if I drop it to there, maybe if I want to maintain a DO of 3, I can do it and I can transfer in enough oxygen. So we have another graph here that's really kind of, so I don't have to go back and forth. Instead of based on an organic load varying, I'm going to vary my mixed liquor and fix my load. So I'm going to say, well, I can change my mixed liquor from 1,500 up to 3,500, let's say. That's the range. And I want to look at, we'll just keep talking about 10,000 pounds. Okay, so we got 10,000 pounds of organic matter to treat. And so what we see here is at 2,000, I'm going to require, 90, it looks like about 9,000 pounds of oxygen. And if I want to run at 2,500, I got to produce 10,000 pounds, so forth and so on. So I can, again, plot these out and kind of talk about or look at what our oxygen requirements are based on different loadings and different ways we can vary our mixed liquor suspended solids. So now I'm getting to play that game of what-if analysis. The next section is just a report that says, how are we doing? Do we have enough oxygen based on how we're going to set up our system? So we're going to say, well, we've got a influent BOD concentration of 100. I've got a flow of 5. My DO target again is 3. And here are my basins and what's going on. And I can evaluate this, and it basically comes in and says what our dissolved oxygen, is that adequate to treat this amount? So again, I can play with these numbers and say, well, what if I up my flow to 8 and I get a higher influent? Now I'm going to be in real trouble. It says, You can consider load reduction, which I always find is humorous because you really can't stop what's coming into your plant, or you can increase aeration. So I guess if you had a holding tank or something like that, maybe that would work for you. So that is the oxygen status evaluation report, and that is the oxygen analysis portion of the modeling. In the next videos, we'll go over the solids production now that we can play with our mixed liquor and see the effect that it will have on our oxygen system. Next, we got to see what's going to happen with our solids production. Thank you.